Welcome to weather. You're going to study all kinds of various weather information in the next 8 weeks. Uh, we're just going to start off this week understanding a little bit what it actually is and monitoring the weather. So, with that, let's see if we can. What are some of the basics characteristics of the atmosphere and the weather? So, weather is the state of the atmosphere at some place in time. In other words, if you walked outside your house at this given minute and you told me the temperature, humidity, clouds, precipitation, wind speed, wind direction, maybe pressure, you are describing the weather. Now, if you wanted to know what it was 15 minutes ago, that's in the past. Or if you wanted to know what it was going to be a couple hours in the future, that's a weather forecast. So, weather is what is happening right now. And meteorology is just the study of the atmosphere and the processes that cause the weather. So, climate, it's long-term averages of weather and weather systems. And climatology is the study of climate and everything that controls it, which includes variables from the earth, the sun, all kinds of different things can go into climatology. How do you get your weather? Well, a lot of you, I'm sure, get it on your smartphones, somehow online, television, maybe. There is something called NOAA Weather Radio, and there are numerous weather apps. One of the interesting things about weather, since we're interested in knowing the weather all over the globe at exactly the same time, meteorologists have developed a convention. The idea is that all weather, when we look at an observation, is related to Greenwich Mean Time, Zulu time, Universal time. So whatever the time is over there, say the time over there was 12 a.m. or 12 p.m. maybe, you would look at Eastern time zone. It's 5 hours different from there to where that is. So our 7 a.m. is the same as noon in England. So, but that noon observation in England is exactly at the same time as that 7 a.m. observation here in the eastern U.S. or the 4 a.m. observation out in the Pacific. They all have to be at the exact same time in order to get the weather. We're not dealing with the weather forecast. We want to know what the weather is. And they all got to be at the same moment in time to do that. This weather is constantly changing. So there are two basic kinds of pressure systems out there, high pressure and low pressure. And then cold fronts kind of separate these systems. And warm fronts. So we're going to discuss these in greater depth throughout this whole course. High pressure, you're generally going to have fair weather, and it rotates clockwise in the northern hemisphere and generally attract towards the east or southeast. Low pressures, generally going to get bad weather with them, and a counterclockwise rotation, and air is rising. And again, they're going to generally track east and northeast. So one of the interesting things with lows is weather to the west and north is usually cold. Weather to the south and east is usually warm around lows. Highs are kind of uniform. And here you can get it reinforced in your mind. High pressure, the air is rotating clockwise. Low pressure, the air is rotating counterclockwise. Air mass. Air masses are just basically a large volume of air, all having the same characteristics. So, think about it up in Canada in the wintertime. High pressure might begin to develop up there, and you're going to have a large area, maybe a lot of Canada, all getting similar temperatures, similar humidities, and you're developing either an Arctic or a polar continental air mass. Now, say you had an air mass that developed over off the southeast United States, Bermuda area. That air mass would be a tropical maritime air mass. So the way these air masses originate dictates what their characteristics will be and how we call them. So there are polar air masses in the winter and in the summer, just a little bit milder, and the tropical air masses as well. And there are tropical continental air masses. The desert Southwest gets those. One of the other things about weather is it's three-dimensional. It's not just in one dimension. So in other words, if you have a warm front, you'll notice the actual warm fronts here moving to the north, and the precipitation is out ahead of it in the cool air. So you can see that this is sloped upwards, the warm air riding over the top of the cold air. Cold air, on the other hand, pushes through, and the precipitation is generally right at the edge of the cold front. So remember that fronts are three-dimensional. Warm front clouds are generally broad-banded, large stratiform areas of clouds with light to moderate precipitation, usually lasting a fairly long time. Cold fronts, you may get a very intense burst of precipitation as it comes through, and a much narrower band. Wind directions are also different on each side of the front. However, especially in summertime, some fronts can pass with no real change in precipitation or cloud cover. Maybe just a slight drop in temperature or a slight drop in moisture. Coastal areas have their own weather. If you went by Lake Erie, you notice sea breezes that occur during the summertime. And in the fall and winters as well. Heavy lake effect snow can occur in parts of coming off the Great Lakes. Tornadoes in the central U.S. So each part of the United States has little bit different weather. If you're describing the state of weather, I would hope you'd want to know what the maximum temperature was going to be today, maybe the minimum tonight. You might want to know the dew point, just a measure of moisture, to know how much moisture is in the air. Relative humidity is another measure of how much moisture, maybe precipitation. At least I kind of like to know if it's going to rain on me or not. Air pressure. And air pressure tends to rise or fall. When you have low pressure coming towards you, the air pressure is going to fall. When you have high pressure approaching you, the air pressure is going to rise. Wind direction and wind speed are something else. Interestingly, in meteorology, when we talk about a west wind, we mean the wind is blowing from the west towards the east, and not the other way around. We're always looking for where the wind or the air is coming from and to where it's going then. So if it's a west wind or a north wind will be coming from the north, blowing towards the south. Sky cover and watches and warnings come out of the National Weather Service, basically. Clouds are wonderful ways of just getting an idea of what is happening in the weather. Sometimes you have the cumulus clouds, puffy clouds, or sometimes you have very thin clouds. And clouds are different depending, think about it. The clouds are very high up, they're more ice, and the clouds are fairly low. Maybe they're more water, so they look different than each one. Fog. Stratiform clouds, like I say, tend to form ahead of warm fronts, and they can stretch for miles. And they'll move at different directions depending on the height in the atmosphere. Cumuliform, more puffy clouds, tend to form in front of cold fronts. And when you're looking, you can see cumulonimbus clouds are very strong, well-developed clouds, very high, and might get lightning and heavy rain out of them. And the key thing, again, if you're looking up in the sky and see clouds, I bet you can see them moving in different directions. And it's just the wind. Remember, the atmosphere is three-dimensional, so the wind may be moving in different directions at each altitude. So with that, I just wanted to show you a couple other things here. Here's a weather map, surface weather map over Ohio. And I wanted to concentrate. You're going to be seeing surface weather maps as part of your labs all full 8 weeks. Well, if I'm looking at a surface weather map, here's what they call a station symbol. This little symbol right here, see the little bar down here to the south? That means it's a southerly wind blowing towards the station symbol, with 10 knots being 1 bar, and the temperature is 75, dew point is 70, and here's the pressure. 1019.5. And part of the circle's filled in, so there's a few clouds there. So that is an observation. That is the weather occurring at that location. And you can look around Ohio right now and see here 2 drops, 2 dots. This indicates rain. Over here, there's 4 dots, very heavy rain. This was just light rain. Here's low pressure. Again, look at the wind. It blows around. It goes from the south on the east side of the low to the north on the west side of the low, the northwest. So what this is telling me is that you have a counterclockwise circulation here. Here's another cold front separating air coming in off the ocean, literally. Cooler air, notice temperatures in the 70s and temperatures well in the 80s back to the west. And if you're interested in a weather forecast, one of the interesting things the Weather Service does do, it produces a weather forecast for very specific locations now. And you can see here, for example, there's Mount Vernon. I am looking at a weather forecast for this square right here. This square is 2 kilometers by 2 kilometers. If I wanted to move it over Mount Vernon, I could move it around to get that. But that would give you the weather. There it did move over Mount Vernon again. And if I'm really curious about things, I can actually look in detail at an hourly weather forecast that Weather Service puts out. And it had a little trouble today. But you can get an hourly weather forecast that will give you an idea, literally hour by hour, how the temperatures are going to change, whether it's going to precip or not. So I hope if you have any questions, you'll let me know.